Good morning, everyone. Okay, today we're going to be doing 7.2 common factoring. It's not an easy lesson, so please pay particular attention to the questions and the examples and come and ask me if you have any difficulty. Okay, please do the minds on if you haven't done so already. So today, by the end of this lesson, you should be able to determine the greatest common factor of a set of terms or of a binomial, and you should be able to factor a polynomial using common factoring. All right, let's go. So it says determine an expression in simplified form for the area of the rectangle. Well, we know the equation for the area of any rectangle is length times width. And we can see over in this particular rectangle, the shorter side, is x minus 7, that's the width, and the longer side is 2x minus 1, that's the length. So we're going to have area equals 2x minus 1 times x minus 7. Now that's length times width, but it asked for simplified form, and so we need to FOIL this expression. So we're going to start, here I'll use red. We're going to start first times first. So that's going to be 2x times x is 2x squared. Then we're going to do the outsides. So this is outside and this is outside. So we're going to go 2x times minus 7. So that gives us minus 14x. And then we're going to start with the other one. Minus 1 times x. That's going to give us minus x. And minus 1 times minus 7. That's going to give us plus 7. Then we have to gather our like terms. So we end up with 2x squared minus 14 minus 1 is minus 15x and plus 7. So that's an expression in simplified form for the area of the triangle. Okay, so hopefully you know how to FOIL. All right, common factoring. So this is just a little recall here. Remember, if I asked you to expand this, you would take this and multiply it by 3x, and you would take 2x and multiply it by 5. So you would end up with 2x times 3x, numbers by numbers, letters by letters when you're multiplying. So 2 times 3 is 6. X times x is x squared. Then for the second set of terms, it would be 2x times 5, which of course is positive 10x. That's expanding, but what we're going to do today is the opposite of expanding. We're actually going to be taking something that's in this form, simplified form, and we're going to go and put it back into factored form. So this is called factored form when you've got one thing times another. It doesn't just have to be 1x times another. This is a monomial, one term, times a binomial, two terms. But as long as it's two things being multiplied, it's in factored form. Okay, so what is a factor? Well, if they're just numbers, then factors are numbers that can multiply together to give you another number. So if I asked you what is the factor of 24, you're going to tell me, oh, a pair of numbers would be 1 and 24. 2 times 12 is also 24. 3 times 8, 4 times 6, and I think that's all. And then we could get into the negatives, but we won't. So that's of the numbers. But you can also have a factor of an expression. So for instance, I could give you this expression, which is a binomial, and I could say, what are the factors of this expression? And you would say, oh, well, 5 goes into that, and 3x plus 2 goes into that. And I know that seems strange. So this is our first factor, and this is our second factor. And together, when we do the distributive law, we get back to our original question. So ultimately what you need to know is factoring is the opposite of expanding, which is what we did yesterday. We did FOILing, and distributive law is also factoring. Sorry, distributive law is also expanding. Okay, so the greatest common factor is we know it as GCF. Is the largest number that divides evenly into a given set of numbers or terms. All right, let's see if we can find some GCFs. So here's an example. Find the greatest common factor of each set of terms. So we've got the number 35 and we've got the number 75. I'm pretty sure 5 is going to go into both of those. How do I know that? Well, 5 times 7 is 35, and 75 times 5. 5 times 15 is also 75. So what we could do is we could say, okay, for 35, we've got 5 times 7. Can we break that down into any other smaller numbers? No. How about 75? We said 5 times 15. Can that be broken down into some smaller numbers? Yeah, it can. So let's try rewriting that as 5 times 5 times 3. So now we're going to look at these and we're going to decide what's common. Well, I can see that the only thing that's common is the 5s. But I can only do this if I've really broken everything down into its prime factors, we call that, so they don't break down any more other than to multiply by 1 or themselves. Okay, so let's look at the next one and see if that makes any more sense. So the GCF in this case, just to go back, is equal to 5. So let's see, 21x, well, I know that it can be 3 and 7. I'm just dealing with the numbers right now. And then 60, that can be, let's pick a pair. So that's 10 times 6. But we can rewrite 10 as 2 times 5. And then we can rewrite 6 as 2 times 3. So if we look at this, what's common to each of these? 3 and 3 is common. So the greatest common factor is just 3. Over here for C, do you want to try C on your own? Just go ahead and try C. See if you can get the common factor. Okay, so for 36, we've got 6 times 6, which is also the same as 3 times 2 times 3 times 2. Those are my smallest numbers. And then for 9x, we're going to have 3 times 3. The x doesn't really matter unless it's part of all of them, so we're going to deal with that in a minute. So 3 times 3, that's as simplified as it can be. And 18x squared. Again, ignoring the x squared for now. We're going to have 3 times 6. That's a couple of factors. And if I wanted to make that even smaller, 3 times 3 times 2, because 3 times 2 is 6. Okay, and then if I look and see what's common, well, there's 2 3's here, and there's 2 3's here, and there's 2 3's, oopsie, sorry, I'm going over to this other one, 2 3's here. So it looks like 3 times 3 is common, and my GCF is 9. Is that what you got? All right, you don't have to break the numbers down like this. If you're able to find the numbers on your own, that's fine. Okay, I'm going to get you to do question number, or the practice A, and then I'm going to do B for you. So go ahead, pause the video and do A, please. Okay, we're back. 32 can be written as 8 times 4, which is the same as 2 times 2 times 2. That gives me the 8. And then the 4 can also be written as 2 times 2. So we've really got it broken down here. And 40, well, we could start off by saying it's 4 times 10, in which case it's 2 times 2 times, what's 10? How about 2 times 5? And again, not being able to be broken down into any smaller little pieces. All right, so let's look for the common factors. Well, I have 1, 2, 3 2's. And I have 3 2's as well here. And then I have even more, but that's as many as I have in the second one. So the GCF of this one is going to be 2 times 2 times 2, and the GCF is 8 then, because 2 times 2 times 2 is 8. All right, I'm going to do this one for you because this one's got an x in it and an x squared. So to find the GCF of the numbers, we're just going to continue to do what we did before. 13 is just 13 times 1. There's no other numbers. 20 is going to be 2 times 10, which can be broken down to 2 times 2 times 5. Do you see anything common there? No, so there's no common number, but there is a common letter. So for x squared, that can be written as x. I don't want to use x, so I'll just use the dot for times. X times x, and for x, that's just x. So what's common to both? Well, just one x is common to both. So in this case, the GCF is equal to just x. If there was a number, then it would be both the number and the letter that could be common. All right, so let's look at 15, 9x, 21x squared. So again, we'll start with 15. Because there's no letter attached to the 15, we know that the letters are not common to all three, and so we only have a common number. So 15 can be broken down to 3 times 5, and that can't be broken down anymore. 9 can be broken to 3 times 3, which cannot be broken anymore. And 21 is 3 times 7, which also cannot be broken down anymore. So what's common? Only 1, 3. And the letter is not common because it wasn't attached to the 15. So the GCF is just 3 in this case. Okay, I know that's tricky and it takes a little practice, but you'll get it. I'm confident about that. All right, so now what we're going to do is we're actually going to factor this binomial. So steps to factoring. Number 1, you're going to find the common factor. So the greatest common factor, the GCF, you're going to put it in front of a bracket. And then you're going to divide each term by the GCF. And you're going to put that answer inside the brackets. Okay, see if we can do this. So it says factor. So we're going to find the common factor. So GCF of 4 and 20 is, well, okay, if we want to do it the long way, we're going to say 4 is 2 times 2, and 20 is 2 times 10, which is also equal to 2 times 2 times 5. So the GCF is going to be 2 and 2. There's 2 common here, 2 2's common to both, right? Each set of these has 2 2's. So the GCF is just 4. All right, so now I'm going to take that 4, just like I said here. I'm going to find the GCF. I'm going to put it in front of a bracket. So I'm going to open up that bracket. Now I have 4 times something, right? Well, what does 4 have to be multiplied by so that I get my answer back? 4 times x gives me 4x, right? Or you could think of it as 4x divided by 4. And that gives me x. And then 4 times what gives me 20? Or 20 divided by 4 is 5. Close your bracket. we could check this to see if we're correct by just doing the distributive law, right? We could take 4 and multiply it inside the brackets. So if we did that, we would get 4x plus 20, and we get the right answer. We get our answer back. So this is the final answer. This is what we call factored. Okay, if I asked you to check, you can give me that last part, but you don't have to. This is the final answer. All right, so what's our GCF for this one? Actually, maybe you should pause the video and see if you can do this one on your own. Okay, so the GCF for this one is going to be, let's see, for the 5, it's just 5 times 1. For 30, we can have 5 times 6, which can be further broken down to 5 times 2 times 3. So the GCF of the numbers is just going to be 5 and 5. And we've also got a situation where we've got common letters. We've got an x and an x squared. So that can be just written as x. X squared can be written as x times x. And then we have a common, oopsie, wrong color, but you know what I mean. We have a common x. So the GCF in this case is 5 times x. It's 5x. When you pull out then that 5x, and you have to multiply 5x by something in order to get 5x, what do you think 5x multiplied by will give you 5x? 0? No, because 5x times 0 would be 0. It's in fact 1. And then what does 5x have to be multiplied to get 30x squared? 5 times 6 gives you 30, and x times x squared. X times x gives you x squared. So it's going to be plus 6x. And again, we could check this. This is our final answer, but if we wanted to check, we would just do the distributive law. 5x times 1 is 5x, and 5x times 6x is plus 30x squared. Do I get what I started with? Yep. All right. Ooh, this one looks tricky. Okay. My advice to you, whenever you have a negative in front of the first term, I would pull that out right away. So don't just pull that out, and then of course you're going to change the sign of each of the terms inside. So we've already got something out here. That's like a -1, remember? And now if you checked and you multiplied -1 by 48x squared, you're going to get -48x squared. -1 times positive 63 is going to give you -63. So that's already factored a little bit, but we still have to see if there's a GCF of the numbers and letters. So let's see. Oh, goodness. GCF of 48 is going to be, let's start with 48. I know is 4 times 12, but that can be broken down. 4 can be broken down to 2 times 2, and 12 can be broken down into 2 times 2 times 3. 2 times 2 is 4, 4 times 3 is 12. All right, and then 63, is 9 times 7 is 63, right? It really helps to have a number chart if you're having difficulty with this. So this would be 3 times 3 times 7. Okay, what do I got here? I only have common a 3 and a 3. So the GCF of the numbers so far is 3. But we need to do the letters. So what letters do we have? We have x squared and we have x. And you've seen before, so this shouldn't take you too long. This is x times x. This is x. and we have one common x. So the GCF is also x. So the GCF is x times 3, so it's 3x. So I'm going to open up my bracket. I'm going to put that negative that was already there from up here in, and then I'm going to figure out what I'd have to multiply negative 3x by to get 48x squared. And I'm not sure what that number is, but I know that 48 divided by 3 is 16 because I did that on my calculator. And I know that x times something gives me x squared. Well, that's got to be x. And then for the 63, I've got a negative 3x, and I'm trying to get a negative 63 here. Right? If we go back to the original, we can see that negative 3x times 16x is negative 48x squared, and negative 3x times something positive 63 divided by 3 is going to be, if you do it on your calculator, 21. And we don't need an x there because we already have an x here, and there's only one x in our original. Okay, we want to check, as per usual, we're just going to multiply the first term by the first, and this term by that one, and we end up with, so I'll just write check so as not to confuse about what the final answer is, because this is the final answer. We're going to end up with minus 48x squared minus 63x. Is that what I started with? We'll just double check. Yeah. Do you want to give D a try? Pause the video and give D a try, please. Okay. GCF. Well, I can see that I'm getting better at it now. Hopefully you are too. And I can see that the only number that's going to be common with 5 and 1 is 5. And 5 does go into the other two. So I know that GCF is 5. I know there's no letters common because there is no letter on the third term here. So only a GCF of 5. I'm going to pull that GCF out then, put it in front, and if I divide this by 5, I'm left with x squared. Or I can think about 5 times x squared gives me 5x squared. If I divide this by 5, that's going to be plus 2x. And if I divide this by 5, that's going to give me 24. Minus 24, sorry. Let's check that one. So if I do 5 times x squared and 5 times 2x and 5 times negative 24, do I get my original question back? Let's see, I get 5x squared plus 10x minus 120. Is that my original question? Yeah. Okay, so I know this is tough. So if you've had a difficult time following this lesson, please come and see me and I'll do my best to help you. All right, we're going to move on to the last example, which is just a quick little word problem. It says the area of a chalkboard is represented by that equation. So area equals 21x squared plus 6x. And it says what are the dimensions? So you know that area is always expressed as length times width for we're assuming the chalkboard is a rectangle. And so I need to get it in terms of something times something else. I've got something plus something else here. But I know that factored form is something times something else, right? Let's go back and look at our factored form. This one is 5 times this trinomial here. This one is minus 3x times this binomial. So again, something times something. So if we can get this in factored form, then we'll have an expression for the length and an expression for the width. All right, so what is the GCF of 21 and x squared and 6x? So 21, we can write that as 3 times 7, and that doesn't break down anymore. And 6 we can write as 3 times 2. Well, of course you can see that 3 is common. So the GCF of the numbers is 3. But let's see, what about the letters? We've got x squared and we've got x. And so you've probably figured out by now that when you've got an x squared and an x, your common factor is x. So we've got a GCF. Let's see. So the GCF is equal to 3 and x. All right. So I'm going to go ahead. I'm going to write the GCF of 3x. So this is going to be open bracket 21x squared divided by 3x. Well, if I go over here and I just put 3x, 21 divided by 3, well, that's 7. X squared divided by x, well, that's just x. Does this make sense? 3x times 7x? That's 21x squared for sure. And then we've got plus 6x. So if I divide through by 3x, these x's cancel, and I've just got 6 divided by 3, which is just positive 2. I'll check this one. And let's just do our distributive law. This is 21x squared plus 6x. Is that what I started with? Check. So, how do we answer the question? What are the dimensions of the chalkboard? Well, we don't have enough information to give actual number dimensions, like the area is 5 and the width is 5 and the length is 6. But we do have expressions, so we can say that the length would likely be 7x plus 2, since that's going to be bigger than 3x, and the width is 3x. And you might want to put conclusion too as well, so therefore the dimensions are length 7x plus 2 and width 3x. Okay, that's it, that's all. See if you can do the consolidate. If you're having a lot of difficulty, as I said, please come and see me. Otherwise, I'm going to expect you to start your class work after that, so it should be on your handout. Thanks a lot.